Hey, sixth grade. Hopefully you're enjoying your little Corona break and that you're understanding your homework. I just wanted to walk you through the last lesson we did. I know I apologize that I didn't get this to you before you did all the homework and whatnot, but hopefully me walking you through this right now will just help to solidify what we did so that you can do well on the quiz tomorrow. So I just wanted to remind you of a couple things. One, work is anytime you have a force being exerted over a distance. And so you have to have those two things. You have to have force, you have to have some sort of movement, some sort of force, excuse me, and then you have to have the object being moved over a distance. So we had talked through the formula. Hold on, I'm just pulling it up over here. And the formula was force times distance equals work. Now I had also put up there that any number times 0 equals 0. And the reason for that is because if you're exerting a force on something, but you're not moving at a distance, then you times it by 0, and that means there is 0 work being done. So for example, if I push against, I'm pushing against my cabinet here, okay? Even though I'm exerting a force, it's not going anywhere. So technically work is not being done because I'm not moving it over a distance. Because even if I'm exerting 15 newtons of force, the distance is 0, which means no work is being done. So I just want to make sure you understood that part. The other thing I kind of wanted to go over with you was your simple machines, specifically levers, because I know a lot of you have struggled with, well, how does a lever work? I don't really understand it. So I wanted to talk about the different types of levers, okay? So a lever is any bar that turns on a point. Now, the part where it turns or pivots, that is the part that is what we call the fulcrum. So some examples of levers are like a seesaw or a wheelbarrow or a broom, and I'm going to explain how all those work. And I'm going to actually use a couple different examples and show you how they work so you understand the difference between them. So you understand a fulcrum is where it does the turning, okay? And then you need to know the effort force and the resistance force, and you were labeling those on your worksheet, right? So effort is where you apply the force, and the resistance is the force that the effort works against, okay? So in a first class lever, your fulcrum is always in the middle. So an example, where did it go? I had a hammer here. Someone took it. Oh, there it is. Hold on one sec. My kids move things on me. And my little thing where you can turn it around is not working right now. So here's my hammer, okay? With a hammer can actually be two different types of levers depending on how you're using it. So when I am using it to remove a nail from something, okay? The part where, excuse me, I'm sorry, my videotaping skills are not amazing. The part where it is pivoting is where? The part that it's moving is right in the center there, right? This part down here. So that's your fulcrum. Now, where I'm putting forth the effort, that's my effort. And then the resistance is the part where it's, pulling out the nail, okay? So effort where my hand is, fulcrum in the center, and resistance is this like part where the nail comes out, okay? Now, because the fulcrum is in the middle, what type of a lever is that? I'm going to pause and let you answer. It's a first class lever, okay? But we can use a hammer a different way, right? Maybe the more traditional way that you think of a hammer is by using it like this, okay? In this particular example, where is the effort? Okay, the effort's where my hand is again, okay? The resistance is where the nail is going down. And the fulcrum is, now I'm forgetting where the fulcrum is. Oh, sorry. The fulcrum is where if I hold it here, the fulcrum's down here by the handle, okay? So that makes, because that's where the part where it's pivoting, okay? So that makes it a third class lever. A second class lever is where you have, and this goes back to that little part of the PowerPoint where it says what's in the middle was the question. How do you tell what it is? So if the fulcrum's in the middle, it's first. If the resistance is in the middle, it's second. And if the effort is in the middle, it's third. So going back to a second real quick, in a second class lever, you have your effort on one end, your fulcrum on the other, and then your resistance is in the middle. So look at this stapler here, okay? Here's a great example of a second class lever, okay? The fulcrum is right here. This is the part where it pivots, okay? That's why there's a screw there. That's where the pivoting is, okay? Where do I put forth the effort? I put it forth right here, so on the other end. And then what's in the middle is the resistance. So fulcrum, resistance, effort. And that is a second class lever. So when you're trying to work through some of the levers and figure out what they are, think about what's in the middle, okay? If the fulcrum is in the middle, the place where it's pivoting, that means it's a first class. If the resistance is in the middle, then, and the fulcrum's on one end and the effort's on the other, then that is going to be a second class lever. And if the effort's in the middle and you got the fulcrum and the resistance on opposite ends, then that's going to be a third class lever. So I hope that helps clear up the lever situation for you. I want to just quickly, I'm pulling up my other notes here for you. Just want to go through the second half of that lesson, which was pulleys. And there were 3 types of pulleys as well. There's the fixed pulley, which doesn't move, okay? All it does is it changes the direction of the force. And so, like for instance, if you want to move something up, a pulley is a great way to do that. It's not going to make your work any less. It's just going to change the direction of the pull, okay? Then we've got, hold on one sec. Then we've got a movable pulley. That is where it's the pulley's not attached, and so it moves. And when you have it moving, sorry, my lighting's bad, it reduces the amount of force that you need to move the object. So if you want to put in, like, if you want to bring up something that's really heavy, you can use a movable pulley, and that will help reduce your force. So anytime you increase the distance, you are also you're going to decrease the force by half. So in other words, if I double the distance that rope has to move, then I only have to put in half as much effort on my behalf. So I'm saving effort, which is what the whole point of a machine is, right? And then the third type is a block and pulley. That's where you have at least one fixed and one movable, and sort of does the same thing. It just helps it reduces the force in the distance. So mechanical advantage, I think has hopefully been pretty self-explanatory, but this is kind of where you figure out just how much you're saving, okay? So, hold on one sec. It's essentially like helps you to figure out how much effort you are actually, or how much force you're actually saving if you increase your distance. And so it's a output over input type of formula. We'll get more into that in 8th grade. You don't really need to get too worried about that for now, but you just need to know that mechanical advantage shows how much of a can't think of the word, how much you are saving as far as your force is concerned, okay? I think the rest of the simple machines were pretty self-explanatory. Wheel and axle is a wheel that moves on an axle, okay? Then we've got the inclined plane is like a ramp, okay? And so with a ramp, you're going to have to deal with things like friction. So friction is going to be a force that's going to affect an inclined plane. So it's not as effective as a lever, but it still does the trick, especially when you don't have a lever available for you, or if you just need to get something up from something heavy from down below, okay? A wedge is 2 inclined planes put back to back, and it helps to split things and move objects. And then a screw is actually an inclined plane that's wrapped around a cylinder. And so that's used to, obviously, It's a screw is used to hold things together and whatnot. And the threads help you to keep something in. So think of a light bulb, right? The end of a light bulb has a screw on it. And when you put it in, that allows it to stay in place, okay? And then a compound machine is anytime you put 2 of those machines together. There was a video that was attached. Hopefully you can see it. If not, let me know and I'll put it on RenWeb for you. We are going to still do that Simple Machines project when we get back to school. So keep collecting your recyclables. And we will make sure to do that when we get back. It's kind of fun, it's creative, and I just figured it'd be easier to do it back at school when I'm with you guys. So anyways, I hope you're all staying healthy and that you're having at least some fun in the middle of all your break. I'm sure you are. And hopefully the homework's not been too hard or too complicated. So let me know if it is. I am going to get onto Kahoot tomorrow for you guys at 1 o'clock. Okay, I'm gonna start up on my end. I'm gonna send you the code. You're gonna have about 15-20 minutes to log on, and then we'll actually start the game. So if you have access to a computer at 1 o'clock tomorrow, that would be great. And if you don't, just study those activity manual sheets. You'll still do just fine. But if you have the ability to get on, then get on. Okay, you can use your phone. You can use an iPad. You can use, obviously, a computer. We've done that at school. Just log on like you normally do at school, and then when I give you the code, put it in, okay? And then I am going to send 9B quiz tomorrow, okay? It's going to be on simple machines, on levers, fulcrums, resistance, effort, all that kind of stuff. So study that 149 to 150 activity manual sheet, okay? All right, I miss you guys a lot. I hope you're all well, and I will talk to you soon.